maybe I can start without opening up the full presentation mode. I just need to switch from here to Google Maps for you to have an impression of what we are talking about.
Yes, all right. If you prefer to have it like this, no problem.
Okay. So good morning again, everybody. My name is Roberto Fedrizzi, and I present a study we have made some months ago already, or even 1 year ago, on the demo site in Trento, together with my colleague Rosanna Paradiso, who is in maternity leave. She made the main job, but she's in maternity leave, so I will present for her. So basically, just for you to understand, the city quarter we are having in focus is this one. It is in the south part of Trento. For you to understand, this is the city center. What you see on the screen is the city center of Trento. I don't know if you have the chance to visit it. And our demonstration site is down here in the south, which is a mixed residential, industrial, tertiary city quarter. Here you see the 3 tower blocks that we have in focus for retrofit purposes. And again, on the screen, you basically see the area which we have taken into consideration for this assessment of what it is, what waste heat availability is on site, and how to recover it in order to cover eventual space heating needs in the 3 tower blocks, but again also in our residential buildings that we have on site. So basically this is it, this is the context. And now in full screen mode, this on the map, what you've seen already on 1 minute ago on the screen, is the place where the 3 towers are located, and the different squares in colors are a number, 40 by the way, a number of productive sites with potentially reject waste heat into the air today. And the idea here was to look into how to, what is the extent of this waste heat in different production sites. And eventually how to recover it in the three towers, in the 3 buildings, as I said before. So what we did is to categorize the production sites. We consider from restaurants to pastries to large, so from very small to much larger productions and tertiary buildings. And we categorize them by site on the one hand, because this is relevant to extrapolate, potential from reference production site that you can find in the literature, as we will see later on in my presentation. And we categorize them also in terms of distance from the 3 So in red, the closest ones, orange, yellow, and then green, the buildings that are in a range of 2 kilometers from the What we did is to share questionnaires with them, with all these companies, and then to call them to gather information by them in terms of their electricity, in terms of their energy use. On the one hand, electricity, but also thermal energy use. Also ask them to tell us, to shortly describe their processes in case, and to identify what are the main uses of energy in their production site, To make it short. Indeed, we also call them to help them reply to these questions and to guide them through the questions. As you can imagine, not all the companies we contacted replied to us. Not all participated. I would say we got a reply from something like 10–20% of the companies, let's say around 10, I would say, and we could work together with closely, more or less closely, depending on the companies. Apart from this, from this introduction, what we did is to concentrate on the companies that we believe are more promising. On the one hand, because of the type and quantity of energy they could make available in terms of wasting, and because actually they provided more information. So here I will present a few of them, the analysis of the waste heat on a few of them, and again I will show you a few examples of the energy that they can make available. The first example is this superstore that is a large supermarket which is located west to the buildings, to the 3 buildings we have in focus. Yeah, it is located somehow around 1 kilometer from these towers. Again, for you to understand what we are talking about, the towers are here, and the superstore is the ground floor. Is the ground floor of this big building with red roofs. With a red roof, so it is quite a relevant one. It is quite a relevant one in terms of size. So it is a medium to large size supermarket. And what we have done is to concentrate on their refrigeration needs, because we know that these chillers that they installed, they are quite big and they consume quite a lot of electricity, therefore also project quite a lot of energy into air. In this case, they have a cooling capacity. They have 2 units, one low temperature for refrigeration cells for fish and meat conservation mainly. But they also have one medium temperature refrigeration, one medium temperature chiller, which is used for the showcases in the shop. The overall capacity, cooling capacity, is more or less all, say, about 500 kilowatts installed, which corresponds to 180 kilowatts electricity consumption. If you have some basic know-how of how chillers work, basically the heat which is projected from the condenser into air normally is the sum of the cooling capacity and the electricity consumption, which in this case is in the range of 650 kilowatts. So for those who are not really technical experts, the ratio between electricity consumption and waste heat in the air is in the range of 3–4 times. Please remember these numbers because we will see that many times in the presentation. This in terms of waste heat capacity, waste heat power that is rejected into air. In terms of temperature, this is what we found. This monitoring data. Sorry for the legend, they are not really well visible, but again, the temperature which is of the heat which is rejected is something like 30 to 45 degrees in between winter and summer. for the low temperature chiller and 28 to 35 degrees for the medium temperature chiller. So again, you can expect to have available between 28 to 45 degrees temperature in the for the waste heat which is rejected into air. In terms of monthly distribution of energy, so now we move from power to energy, which is made available. You see that the medium temperature chiller rejects into the air something like 1,300 megawatt hour during the year on a yearly basis. The low temperature chiller something like half of that, so 750 megawatt hours a month, a year. So again, for those people who are not really in the technical side, this does not say much. So here I report what is the quantity of energy that the heating demand that is needed by one of the three tower blocks. So each of the three consumes something like 50 megawatt hours for heating and domestic hot water in December and January, and over 1 year they consume 360 megawatt hours. So when we compare to the previous one, you see that basically the small chiller, the low temperature chiller, can cover of the superstore can cover almost all the heating demand on a yearly basis of one of the tower blocks. And if we consider of the three tower blocks, sorry, and if we consider the two chillers, obviously we can cover more. This is obviously, however, a very large shop. It is not that we find many of them in our cities. And for this reason, we wanted also to compare what happens when you consider a small shop, a small city quarter shop that we can find in our multifamily houses where we live. So we identified a small one, which is in the range of 200 meters from the three towers, which are here. That is a very small one. Cooling capacity 15 kilowatts for showcases and for the small refrigeration cell that they have installed. And also in that case, the waste heat that they reject into air is again in the range of 360 megawatt hour per year. Again, even a small shop like that one can cover the heating demand of one of these big towers, so 50 apartments. A lot of waste heat reject. We want also. Apart from supermarkets, we want to also concentrate on wineries. Trento is there is a lot of agriculture there, apples and vineyards, quite a lot. So wineries are quite common in Trento and the neighborhoods. And we identified two in the area, one in the south side, around 1 kilometer from the towers, and then another one in the north side of the area, of the demonstration side, around 2 kilometers from there. We contacted them, but they didn't want to share, or they didn't know much about their energy consumption for processes. They had a quite good overview of the overall consumption, but they didn't know exactly how the energy was consumed through the year and in which processes. So basically, we came to know what the overall consumption, electricity mainly, was on the two sides, but we couldn't know what was the distribution over the year and in which processes. So what we did is to look into open literature, and we looked into how, these wineries consume energy for what processes and over the year. And obviously, as you can imagine, most of the electricity consumption, most of the energy consumption is electricity. Most of the electricity consumption is concentrated in August, September, partly October, and this is due to refrigeration of the barrels during summer. This is mostly for white wine, and also for the production of the wine during harvest. Again, what we discovered is that 50–70% of the overall electricity consumption in a winery is related to refrigeration. So again, also in this case, we concentrated on chillers, waste heat from chillers. We, for the two companies that we focused on, we extrapolated what is the electricity consumption for the wine making and wine conservation over the year, based on the sizes and based on the extrapolated from the literature review we have made. And then, without going into many details, we said, okay, August, September, October is more or less the same consumption, while for the rest of the months is much lower consumption. So we concentrated, more or less the same use and waste heat, therefore, use of electricity and waste heat, therefore, in these 3 months. This is the electricity consumption for the two companies, and again, this transforms or results into a waste heat that today is rejected into air of 3 times more or less 3 times more. This factor 3 I was telling you earlier before, which is again something like 1.56 gigawatt hours per year made available by these two companies over mainly over these 3 months of the year. Again, the outcome is that of the analysis is that while the energy made available by the superstore is quite constant over the year, the wineries make this energy available only during in addition to this, we also identified another food processing factory, which is in the area. This again, the supermarket. The food company is just in front of that, and it is much bigger because it is this area. So they have a huge electricity and energy production and energy consumption in general. Over there, again, they cannot tell you exactly how the process is made, but we looked into the literature, how these companies work. There are many producing jams and juices. Also, in this case, we concentrated on refrigeration, which is quite a good part of the energy consumption, electricity. Heat losses in the different processes, they can be very much higher than the electricity need for refrigeration, but again, not really easy to calculate or to estimate. Estimation of waste heat in from these processes, without going into too many details, are in the range between 6 and 40 gigawatt hours per year, depending on the kind of process they are there. We couldn't enter into too many, we didn't access to too many details there. Imagine that on average they could make available to the site something like 20 gigawatts hour per year, distributed equally over time. Again, to give you an impression of what we are talking about, this is it. This is again the thermal energy consumption. Remember, 360 megawatt hours per year, and here's what you have from superstores, small supermarket, wineries, over the year. So this is in the range of 1,000 megawatt per month. So a huge quantity of energy which is dumped into air normally, and which we could eventually recover. So this is the potential analysis. What we did is to look into how to recover it, and how to make it is again district heating. Another way, shape of district heating compared to what we have seen in Spain before. So this is low temperature distribution, meaning that you can distribute the water in the district heating at something like 20, 30 degrees instead of distributing at something like 70, 80 degrees like in conventional methods. And then when this low temperature water reaches the customer, the building of the customer, then over there you have a heat pump that raises the temperature of the heat from 20, 30 degrees to what you need for heating and for domestic water. Okay, so in each of the customer buildings, you might imagine that we have a system like this, similar to a geothermal heat pump system that raises the temperature from 20 degrees to something like 30, 40, 50, whatever is needed for heating domestic water purposes. What is the advantages of using this low temperature distribution in district heating? The advantage is exactly that you can recover low temperature waste heat from different sources, as we saw in my previous slides. When we look at waste heat from refrigeration systems, for example, waste heat is available at 30, 40 degrees, so you cannot recover it efficiently in conventional networks that are operated at 70, 80. You need to recover it in this kind of special networks, distribute it, and then rise the temperature in this way. In our case in Trento, this kind of system is waste heat recovery would be quite because in Trento, in the 3 towers, we are going to have geothermal systems installed, geothermal heat pumps installed. They are going to be connected to a geothermal field which construction is foreseen starting spring next year. So in this green area here. And again, in each of the 3 tower blocks, we will have one heat pump. So again, connecting this geothermal system to waste heat that is coming from this production site, as I showed you before, would allow to improve or increase the temperature of the water from the ground, and therefore increase the performance of the heat pumps in each of the dwellings, and therefore again reduce the electricity consumption. So this is the rationale behind, and here we have made a small feasibility understand how to bring waste heat, for example, from the superstore, the first I showed you, all over the street to the three tower blocks. Obviously, the length of the pipeline would be longer than 1 kilometer, but more or less there we are. So basically, the system would be very easy, and it would consist of an heat exchanger that interfaces with the existing chillers in order to recover the waste heat instead of dumping it into air. A pipeline that goes from the superstore to the three towers, and again, another heat exchanger to interface with the geothermal system that is going to be there. Here are a few details. The capacity of the heat exchanger, so the capacity of the system, of the waste heat recovery system is in the range of 200 kilowatts, which again, if you remember, it is the size of the low temperature refrigeration system, so the small one. We thought we can distribute say low temperature water from the superstore to the tower at something like 30 degrees. And what we have done is to consider if we can distribute these either with insulated pipelines, like in a conventional district heating, or if we can use, say, non-insulated pipelines, plastic pipelines, polyethylene pipelines, like the ones that you use for cold water distribution, say, just for you to understand. Without going into too many details, these are the results. This is the distance to the towers, non-insulated pipelines, insulated pipelines, and this is the quantity of energy that you can convey to the from the superstore to the three towers. As you can see, if we use non-insulated pipelines, the heat losses are quite relevant. They are more or less 50% of the energy that is potentially available. And also the temperature that we can deliver is much lower compared to using pipelines. Indeed, the investment cost is a little lower, but this absolutely does not justify the savings on the investment do not justify, say, the heat losses that that you have along the pipeline, along the tank. So again, if we look into return of investment, here it is longer than 25 years, so no investment, no go. In this case, it is 8 years. Again, a bit long, but still feasible. We looked also, just as an exercise, we looked also into how this figure changed in case, instead of considering the three demonstration sites, we considered the three tower blocks, exactly the same tower blocks, but located very much closer to the superstore. In this case, the figures are really different. The heat losses in one case or the other are more or less the same. A little lower temperature made available, but again, in this case, return of the investment, which is in the range of 3 years. So again, a return on the investment, which is interesting, probably also for private investors or other than public ones. Okay. So this is it by my side. A small feasibility assessment and feasibility study we've made. I'm not sure if we are going to be able to actually implement this waste heat recovery in Trento by the end of the Stardust project. But again, interesting topic for Trento, and actually a topic which is becoming more and more interesting over Europe for sure. We are in many European projects that are focused on district heating, and again, we have many practical examples in which supermarkets, data center companies are now providing waste heat to district heating. So again, here just a name or just a suggestion, an inspiration for you to have. If you are interested in the topic, please feel free to come back to me, and I will be more than happy to give you more information and more examples of implementations over you. Thank you all for listening, and hopefully I haven't been too long in my presentation.
Thank you very much, Roberto, for this inspiring and really interesting presentation. As you said, I think that the waste heat recovery potential is something that is important everywhere, and this is a concept which could be replicated across Europe, and this is something which is gaining importance nowadays. So it is a very interesting topic. And I believe there are any questions from the audience. I know that Yanis from Kozani was specifically interested in having this presentation, so maybe Yanis, you would like to get some more details or ask a question.
Yes, absolutely. Thank you, Martin, for the pass, and thank you, Roberto, for the very interesting presentation. Very interesting, and even more interesting for Kozani, who is, as we've said many times, is going to face the decarbonization process, so in need of heat and maybe cheap heat. I don't know if it's very cheap, but anyway. So I noted two things I wanted to ask you. You mentioned it works with low temperature DC heating. This is not the case for Kozani. It's operating, I think, if I'm not wrong, something like a bit less than 90 degrees and the returns of 60 and 70. So my understanding is that it might not work here. I don't know. That's question number one. And the second, I didn't exactly understand. How is the relation with the sellers, or are they sellers? I mean, the supermarkets, do they sell the heat, or you made an agreement and they just provide the waste heat for free? Or can you elaborate a bit more on that?
Yeah. So coming to the first question, high temperature. Say in our say elaboration, in our calculation, we have a heat pump in each of the multifamily houses, and this is because this is our case. Basically, we have the heat pumps already there, and that is the easy way of doing it. There are cases in which waste heat, you have a heat pump on the factory side of the waste heat production, or waste heat production side. Is not production exactly, but you understood myself. So the heat pump is not in the factory side, and rises the temperature from 20, 30 degrees again to the temperature of the district heating itself. Technically speaking, again, and depending on how recovering at this high temperature is not too much effective. Meaning that you need to use a lot of electricity to rise meaning that the COP is low. Therefore, you use a lot of electricity to rise the temperature from 20, 30 to the temperature of the network itself, 70, 80, 90 degrees. You can recover in the return pipe, but again, this is to be evaluated if it is valuable or not, suitable or not. So it is, from the technical point of view, the calculations show that it is much better to distribute at low temperature and then use the heat pump at customer side than doing the opposite. Okay. This said, it is not impossible to do. It is more electricity. You consume more electricity. This said, however, we have cases in which, for example, these low temperature networks are used in extensions of the existing networks. For example, instead of having geothermal probes like this one, you can imagine a low temperature distribution network like this one, which is connected, which is driven by the return pipe of the existing high temperature network. Okay. And then in this low temperature network, in this low temperature extension of the existing network, then there you have waste heat recovery. Okay. And that is very effective because, again, you can drive this network, this low temperature network, with the high temperature network also during summertime. And again, you can use this technique to extend the high temperature network where this would not be suitable from the valuable from the or viable from the economic perspective. So it is not said that the entire network needs to be high temperature. And this, I think, replies to the first question. What was the second one? Sorry for asking.
The second was about the relation with the supermarkets. Are they selling this heat? Is it for free, etc.?
Yeah, sorry for asking again. Indeed, there are different business models. We have cases in which, for example, practical cases, not in Trento, in which the company is open to provide waste heat for free to the network because they can dump, because dumping waste heat into the network is more convenient for them in terms of saving electricity for the chillers than dumping waste heat into air. Okay, imagine that here in the network you always have 20-30 degrees, for example, or whatever in south of Italy. In summertime you have constantly more than 30. Okay, so and you reach during days 40, 50, or 50 maybe is too much, or 40 for sure. Okay, so having 20 degrees heat rejection is much more convenient for them, and they provide for free. In this calculation, just to be on the safe side, on the conservative side, we consider the supermarket sells heat, waste heat to the network for a very low price. However, imagine that in Italy, gas price is in the range of 9 cents per kilowatt hour. Waste heat, we consider it at 1 cent per kilowatt hour. Okay, so 1 or 2, I don't remember, but say 10-20% of the gas price. Okay, and this is the result. So it depends. To reply to your question in a direct way, in the waste heat price can move from 0 to obviously low price, 1-2 cents. Otherwise, it doesn't make sense for the utility from an economic perspective. I don't know if this applies to your question.
Absolutely, yes. Thank you. Thank you very much. I sense that given the situation in Kozani at the moment, but also in the coming years, I sense that this is a topic that might be even more interesting in the, I don't know, in the next few years, before the decarbonization is finalized in terms of these lignite plants. So in essence, being a follower city in Stardust, would be nice to lead to a follower city in another district heating related project. But yeah, let's see for that. I think that would be interesting for us to prepare for the future developments, not for the immediate developments. That's what I understand. But thank you. Also, the example of the set, as you said, the secondary or the minor network grid, that was very interesting because the DC heating company is examining potential extensions. So there we might have some huge interest in developing. Okay, thank you. We can talk for hours, I think, for this.
You're welcome. Feel free to come back to me.
Thank you very much to both of you. I don't know if there are any other questions to Roberto or to any other speaker. So don't hesitate, from Cluj or from Derry. If there are no questions,